All right, hello everybody. This is Stats 1.8 on percentiles. Let's talk a little bit about this. I've got my pre-written notes on here. I'm just going to kind of run through it here, so let's get to it. Percentiles. Okay, so in order to work with percentiles, we must rank our data in order from least to greatest, or lowest to highest. Percentiles divide the data into 100 equal parts. Okay, percentiles measure position from the bottom. Values are assigned 1 through 100, which are whole numbers. The 35th percentile separates the lower 35% from the upper 65%. So this will make a little bit more sense as we get into an example. So let's go ahead and take a look at an example. But before we do, let's talk about how to determine a percentile. Okay, so let's say that you have 10 racers, right? Sprinters, and actually let's go even simpler than that. Let's go 5 sprinters, and each of their times for like the 100-yard dash are as follows. And we'll go from least to greatest, right? And actually in sprinting, I suppose you'd want the least to be the longest time. So let's go like 13.1. 11.7, 10.6, 9.78. These are fast times for the 100, and 9.72. Okay, so for this particular example, because sprinting, the lowest ranking would be the slowest time, we would put these numbers in descending order, but typically we'll put them in ascending order, like for height or for something like that. Okay, so we have 5 positions, right? 5 number positions. And if we want to know the percentile for, say, I don't know, let's go here for this person. We take their position. So position is determined this way. 1, 2, 3, 4, and 5, where the slowest time is the first position and the fastest time is the last position. So we take their position, which is 2, we divide it by 5, and we determine its percentile. I'll call it P out of 100. So proportionally speaking, then if I multiply across, right, or cross multiply, I get 200 is equal to 5P, and thus P is equal to, what would that be, 20? No, that wouldn't be 20. How about 40? Yep. So this particular racer would be in the 40th percentile, which makes sense. They're number 2 out of 5, so the 40th percentile makes sense. Okay, let's look at another example here. The math test scores were given as follows. I've already done the work to put these in order, or rank them from lowest to highest. Find the percentile rank for a score of 94%. Now, 94% is not a percentile. That's the score achieved or attained on the test. So what we do is we put them in order, okay, from 80 up to 98, and then we use our same ratio, right, that we looked at on the previous slide. So we find the rank number, right? Our 94% of the test was the 8th place in order. We divide it by the total number of tests taken. We set it equal to percentile over 100, and then we solve. It looks like this particular person was in the 80th percentile. So a 94 on a test is a really good score. But this kind of gives us an idea of where they compare to their peers. So they're kind of in that 80th percentile. So there were 20% of students that scored better than them and 80% of students that scored worse than them. That's pretty good. Okay, so let's look at a little bit more complex scenario here in the next example. Okay, here are 19 test scores that were given. We rank them least to greatest. I want to bring your attention to something very important here. I'm going to count these out. This is our first test score, second test score, third, and fourth. Well, we're not going to rank either one of these 3 because they're both the same. Okay, so when we get to a situation where we have multiple test scores of the same score, we don't count that lower number, right? We just skip a number and we call these both ranking number 4. The reason we do that is because then we'll still get the same number of test scores at the very end. Okay, so here we go, 5, 6, 7. So instead of 8 and 9, we just get 9 for both of these. 10, 11, no 12, so we get 13 for both of these. 14, 15, 16, no 17, we get 18 for both of these. And we've got our 19th test score here. The reason we give this assign each of these one value is because they are exactly the same. And that keeps the integrity of the process in place the whole time. Okay, so let's look at a 90. So to score a 90, we look at the ranking, that's our 14. We divide it by the number of tests, which is 19, set it equal to percentile over 100. And we work our way down algebraically and we get this. So you can pause the video and see if you get 73.68 as well. Whenever we work with percentiles, we always round down anything that is not a whole number. So this would be the 73rd percentile. For a score of 84, this is a little bit different. We're going to consider one of these duplicate scores. We take the ranking, which is 9, we divide it by 19, total test scores, and set it equal to the ratio percentile over 100. It comes out to be 47.37, which is the 47th percentile. So if you kind of look at this, as a continuum, right, this is about where, the halfway mark is. So it makes sense that the score of 84 would be less than that 50th percentile, right? So that makes sense that that'd be in that general vicinity. You got to have a little bit of logical reasoning as you work through these. And a score of 90, right, 73rd percentile, well, here's the 90. That, just distribution-wise, looks like it's, kind of right on the edge of that 75th percentile. All right, so you can kind of split the data up into quarters, right, and kind of look at it that way as well, just to make sure you're in the right ballpark. Okay, let's continue to another question. Okay, the math test scores were as follows. Find the score for a percentile rank of 21 on the test. Okay, so now we're not necessarily looking for the percentile for a particular score. We're looking for a score that matches a certain percentile. So again, we rank. This is score 1, 2, 3, and 4, just like it was on the previous problem. 5, 6, 7, 8, and 9 become just 9 because they're duplicates. 10, 11, duplicate 13, all the way up to 19. So how do we do this? We take the percentile we want, and now instead of having an unknown here as percentile, we put the 21 in over 100. Now we're looking for the position number, right? So the position number will be one of these. Okay. All right, so we use our understanding of proportions to cross multiply, use algebra to find this, 3.99. Now, in this case, because of where this is located, right, this is really close to 4, we round up to 4. So the fourth position would be the 21st percentile. So a 72 would be the 21st percentile. If I split this into, fourths, we can kind of see that makes sense, right? So as I split it into fourths, I would expect below that to be in that 20th percentile or close to it. And so that makes sense logically. Let's look at another example here. Oh, hey, fun. That's it. All right, guys, I hope you learned something. I'll see you in the next video.